Hi and welcome to Delphi Con 2021 and development for the Raspberry Pi with Delphi 11. And yes, it is true. You will now be able to develop applications for the Raspberry Pi, the tiny little computer that is very much affordable with Delphi 11 without any additional hardware. You can do it from your Windows PC. Even if you don't have a Raspberry Pi yourself, you will be able to generate the binary that can be executed on the Raspberry Pi. So this is how I structured this session. First of all, I'm going to give you Delphi's strength, why you use Delphi. And then I'm going to give you a motivation why to build web applications nowadays with TMS Web Core. And TMS Web Core does not only give you the ability to build web applications, no, with TMS Miletus, you can build web-based applications that you can compile for the desktop so that they run on multiple platforms. And the Raspberry Pi happens to be one of those platforms. The example scenario that I'm going to show is a temperature and air quality monitor which runs on your Raspberry Pi. There's many usage scenarios in the industry nowadays. For example, if you run a property management company and you want to monitor the temperature and air quality in the properties that you manage, you could put a Raspberry Pi in each of those locations. And then these Raspberry Pis would be able to report to the backend the temperature and the air pressure and the humidity in those rooms. Here in Florida, that's a big deal. You can monitor your AC performing well and the humidity being low, and will prevent damage to your property. And the scenario I'll show here will make it affordable because placing a Raspberry Pi in one of those properties is not a big deal. I'll show you the measuring client built for the Raspberry Pi. I'll show you the web service with a Firebird backend that will store all the information collected from one or multiple devices. And then we'll see a VCL front end to chart the data and to show the current temperature that is being measured on each of the devices. And as an aside, I'm going to show you that the web service that we're building is in no way tied to any Delphi libraries. You can use these web services and integrate them into any application that you want. One example for this is an iPhone client written in SwiftUI, let's say by a fictitious other customer that wants to use your API. In the end, we'll do a Q&A live. This part of the session is recorded. Why do we use Delphi? Because it's an object-oriented programming language. It is known for making the development of database-driven Windows desktop applications really easy because of its rapid application development approach. You add a form, you drop the visual controls, you link the database controls to your database, and you run it, and boom, you have a working database application. There's also a huge third-party market for additional visual and non-visual components, TMS software being one of those third-party partners. Native code make the interoperability with any device easy. Of course, initially Delphi was only considering Windows, but now with the FireMonkey framework, you can also do cross-platform development and access the hardware of those devices. Back in the day, network access was also easily possible, and then web components were added for HTTP, FTP, Indy being one of those that's being even integrated into Delphi. However, the requirements changed. Developing for one platform is no longer enough. You need to not only develop for Windows, you also need to supply macOS solutions, Linux, and sometimes even for the Raspberry Pi, because Raspberry Pi is the platform that makes accessories like temperature measurement, monitoring other devices easy because it is so close to hardware. You can even think of the Raspberry Pi as a mini PLC. And of course, you should not forget the smartphone and tablet market, Android and Apple iOS dominating those. With Delphi, you can supply solutions for all of those. However, the development challenges that arise are that you have to make your product compatible with multiple platforms, and one of those solutions is to use FireMonkey instead of the VCL. Still, you would have to build different user interfaces for each of the different clients. A user interface that you build for FireMonkey is hardly ever suitable for a mobile device. It's very difficult to build a user interface that's suitable for both. So I would say you always need custom development for each operating system. TMS has the framework neutral controls, which make this much easier, as you can use the same controls in the VCL and in FireMonkey. So you don't have the learning curve for different frameworks. In addition, framework neutral controls are also available for the web, meaning TMS Web Core. So it only makes sense to take the next step. Target all platforms and all devices with one application. And the only thing that all the platforms really have in common is an HTML5 compatible web browser. Migrating your existing projects to the web or starting all your new developments on the web kind of makes sense. So how can you develop those web applications? TMS Web Core might just be the solution you have been looking for. You can do web development using the same concepts that you've gotten used to. You can do object-oriented programming with rapid application development. You have a ready-to-use toolkit that includes user interface control. You can easily access any web services and other popular cloud services. And you can integrate existing libraries, JavaScript libraries in this case. Xcopy deployment is guaranteed. You just have to copy the parts of your web application. You can deploy TMS Web Core applications to any web server. And it is truly rad. You create a web application, you can drop components and controls on a form, run and debug from the IDE. It's crazy. You can even see Delphi code inside of the web browser when you debug your applications. The combination only creates HTML, CSS, and JavaScript files. There is no server executable. The application types are a standard web client application or a mobile application that is specially designed for iOS and Android because it also detects if you are online or not, and if you're offline, it will use the cached version on the device that has previously been downloaded. This makes using your applications in mobile scenarios possible. And third of all, TMS now offers desktop applications built on top of TMS Web Core using the TMS Miletus framework. That way, you can build installable desktop applications for Windows, macOS, and Linux, and the Raspberry Pi. TMS Miletus supports Windows, macOS, Linux, and the Raspberry Pi. And what you see here is also the different versions of the operating systems that are supported. You can see that Windows you can address 32-bit and 64-bit, and all other operating systems are 64-bit only. And internally, this all is made possible by using browser technology that's being provided natively by all these operating systems. That means with Windows, it's Edge Chromium. For macOS, it's Safari. And for Linux and the Raspberry Pi, it's WebKit. However, the users of your application do not really notice that your application uses this technology. And don't worry, TMS Miletus makes it possible to access local resources, meaning the file system and hardware, which is normally not possible with web applications. But Miletus contains technology that bridges the world of the web browser to your local computer. This makes even the implementation of web services to use databases obsolete for Windows, macOS, and Linux. You can use specially designed database controls to access databases on Windows, macOS, and Linux. Let's look at the scenario that we're going to build. On the left, you see the application running on the Raspberry Pi. We are going to measure the temperature, the humidity, and the air pressure using sensors attached to the Raspberry Pi. It is called the BME280 module that we're going to use. And this application will send its data to a web service. This web service can then be accessed from any device all over the world. For example, here you see an iPhone with running a native application written in a completely different programming language, displaying the latest measurement. In this session, you'll see how to build a VCL client for the web service. The web service is driven by TMS Xdata technology. TMS Xdata will make it possible that you will only have to write a couple of lines of code to create this application. The whole communication aspect, the encoding of the JSON or any other data packages, is completely abstracted from. In a nutshell, you can work with T datasets and T data source to show this. Multiple devices will be supported. Here you see we selected the outside device for a certain date and the measurement that is supposed to be displayed. It might look strange at first that the temperature goes up and falls down like this. However, this is the normal progress of temperature in a house in Florida. At some point, the AC kicks in and the temperature drops and it raises. However, what you see here is at night, the cold front hit and the temperature stagnated and the AC didn't kick in anymore. So the room stayed warm, but the temperature didn't increase. You can also plot the air pressure, which is another value the web service provides, as well as humidity, which is not shown here. You will see it's completely built using rapid application development principles. Buttons, labels, combo boxes, a memo control, a timer control, a control to contact HTTP servers, so we're not using any Xdata specific controls. We're using an HTTP request and we send data to the web service, and a component written by TMS software for TMS Miletus to communicate with the accessories on a Raspberry Pi. And also the charting application for the VCL will use rapid application development using combo boxes, which are fed by datasets and data sources. No code has to be written in order to retrieve the data from the web service. If you want to reproduce this example, all you need is a Raspberry Pi with a BME 280 module, RedStudio or Delphi 11 with a trial or full version of TMS Web Core and TMS Xdata. And if you're interested in the Swift UI client, Apple macOS with Xcode 13 and an active Apple developer account. The budget you need to calculate for the Raspberry Pi and hardware is roughly $150. For the settings on the Raspberry Pi, don't fall into the same trap that I did. In the preferences, you have to enable that you want to use the SPI I2C serial port and serial console in order to communicate with the accessories. By default, these are all disabled, so when you run the application to measure anything from the external hardware, will not work. Let's start by describing the functionality of the application first, and then I'm going to introduce you to the different parts, and then we're going to look at the different parts in code. And I can definitely say it's all written in Delphi, and it is all possible with the RedStudio IDE. You looked at the hardware and you saw the measurement devices that measure the temperature and the humidity. These devices are being queried by the Raspberry Pi. They're directly connected to the hardware interface of the Raspberry Pi. And the Raspberry Pi communicates with the database that stores the information, the temperature, the humidity, the air pressure, in a database. So we need a database structure, and we need the application for the Raspberry Pi. And we need the interface so that the two can communicate with each other. So we use a web service. The web service is written using TMS Xdata. The database is implemented using Firebird because it's freely available. And the application on the Raspberry Pi is a TMS Web Core application compiled for the Raspberry Pi using TMS Miletus. And then if you have this set up, you can deploy as many clients as you want. For example, in this session, I'm going to introduce you to the charting application that makes use of some additional TMS Xdata functionality that you don't need. You can write any client, and as a proof of concept that it can be any client using the data, I also supplied an iPhone client, even written in a completely different programming language. So TMS Xdata is not a requirement for any of the clients, and it's most definitely not a requirement for a client that writes to the web service. So reading and writing is not really making any difference. Let's start with the database. We not only want to be able to have one device, we want to be able to measure values from multiple devices. So we start with the devices table. The devices table has an ID field, a name for the device, and of course I added, for later considerations, longitude and latitude, where the device is, and a description. The key is the ID of the device so we can reference it. And the data points for each device are in a separate table called data points with an ID, date, time, when the values were measured, the value for the Fahrenheit, the temperature, the humidity, the reference to the devices table with the foreign key constraint, and the pressure, the air pressure. All values are float values, and datetime, of course, in Firebird is a timestamp. That's it. That's all we need to do for the database backend. Everything else will be handled by FireDAC in Delphi. After defining the database, we can concentrate on developing the applications and the web service. For the client application that measures the values on the Raspberry Pi, we use a TMS Web Core TMS Miletus application. If you think, oh, that sounds so complicated, it must be really difficult to create one of those applications, TMS makes it really easy. File, New, Other, and then in the TMS Web category, you find the TMS Web Miletus application. Be sure that it doesn't happen to you what is just happening to me here. The TMS Web Miletus form is a form inside of an existing application. Be sure to scroll down, and there you find the TMS Web Miletus application. The reason is why I see the form as well is I already have opened the Raspberry Pi application, so Delphi is smart and shows me options to extend that application as well. So after creating that application, you'll see a form, just like you're used to from building Delphi applications since version 1. And you can drop controls on the form. For example, here you see a TWeb button, the start button, which is supposed to start the reading process from the measuring devices, and stop reading to stop the process. Also, simple labels to display what has been measured, the temperature, the air pressure, and the humidity. In order to communicate with the hardware interface on the Raspberry Pi, TMS Miletus has the Miletus Raspberry I2C component, which allows you to communicate using this control. And it also allows you to define events, how to open or what happens after opening the interface. And here you see something that has been provided to me gracefully by TMS, because I would not be able to build something like this. These are not my skills. Bruno Ferenc and other engineers at TMS are the experts regarding electronics and all these things. How to do this is pretty easy to read up. TMS provides the documentation in the comments of the source. So if you're interested how the measuring device, the BME280, works internally, open up the datasheet and look how the different bits and bytes are encoded on the hardware interface. For this talk, I want to focus on the structure of the application and what is involved in order to build it. Because the project structure in the project manager changes a little bit if you work with a TMS Miletus application. As I said, it's a web application at its core, so that's why the extension of the project is .web. But you don't notice this. Like the compilation will be an application for the framework or for the platform that you select. And you do not use the target platform, which is something that is integrated into the project manager by Delphi. You use so-called build configurations. And here you see all the available platforms. If you want to compile for the Raspberry Pi, you select Build Raspberry Pi or Debug Raspberry Pi. Debug adds, as the name says, debug informations to the executable, whereas Build is a release version that contains no additional information. And this is really possible as is without any additional hardware on your network. You don't need to start a PA server. You can just start the compilation this way. So if I want to create the Raspberry Pi version of the application that you see here in the form designer, Control F9, and the compilation to the target platform starts. And I'm talking while this is going on. The obfuscation also happens because a web application is JavaScript that is being obfuscated so that people can't read your source code that easily. So that's it. This is all it takes to get a Raspberry Pi application with TMS Miletus. And let's say you want to offer a Linux version as well. Well, then you simply double click on, for example, Debug's Linux 64, Control F9, compile, and this is how easy you create a Linux application. You find these applications by right-clicking, show in Explorer. Then you go into the TMS Web subfolder of your project, and there you find the two different applications. One is for the Linux 64, and the other one is for the Raspberry Pi. You can see here's the executable, and here's a link that you can drop on the desktop. Of course, it is possible to build any application also for Windows. However, this doesn't make any sense in this case because we use the Miletus Raspberry Pi specific components on the phone, which don't work on Windows. So how does this application work internally? So start reading starts the timer, and the timer then triggers the process to read data from the I2C interface using read buffer commands. And what is being read is determined by the documentation. It's raw values that you can then show in your label captions. I really don't want to focus on these technical details, how to get the values. The source for this is available if you want to reproduce this. It's much more interesting to see now that if you have the application on your Raspberry Pi, how this application can communicate with the outside world. Because if you have your data on the Raspberry Pi, it would require you to do a remote login or store the information on a network in order to access it. It makes much more sense to use a web service in order to store the information on a database that is then accessible from other clients, so you can create charts of your data or just see the current temperature of that is being measured. These things are all possible using a web service. So how can we create a web service so that our Raspberry Pi application can store its data in a database and other clients can access that data without accessing the database directly? Well, again, TMS has a great wizard, file, new, and then other TMS data, and you can create a new TMS data VCL server. After creating the server, you create services that run on this server. For example, here I created the iData service, which is responsible to give information about the data that is stored inside of the database, and also gives clients the ability to store data and read data. So the most obvious thing to implement is we need the ability to see which devices are available. So you can call devices and get a list of the devices that are stored in the database. It should also be possible to read the last measurement that has been taken by a certain device, identified by its device ID. Furthermore, we should be able to add a data point and get data points within a certain range, for example, a day or 2 days. And you also need to be able to know which dates are even available inside of the backend. I mean, just trying certain dates doesn't make any real sense. What has to be pointed out for the service definition is the fact that you use types defined in Delphi. You don't do anything that is specific for a web service. Furthermore, I made the web service a little bit more cooperative when it comes to date values. I decided to use simple integers. Xdata would be able to handle tdate time just as fine. Thinking of other platforms, it's much easier to use something like epoch date or Unix dates to handle date time stuff. So I decided to use integers for that. The model itself is pretty easy. For example, the data point is just a representation of the stuff that is stored inside of the database. So the ID is an integer. You see I have two fields. One is an integer for the date time. The other one is a date time. So I can read it easily in Delphi. I have the temperature, I have the humidity, normal, double values. The device, same thing, just a representation of what is inside of the database. Then, as we not only need one device and one data point, I defined generic lists,tlist, tdevice, and tlist, tdatapoint. That's more or less it. These are the types that are being used as a representation, what is being returned by the web service. Same for the dates. The dates that are being returned are the date itself and the number of data points on that date as an additional information. So looking back at the presentation, or as at the representation of the service interface as it's formally called, this is how you can define your services, and this would be something that you would supply to your customer who wants to use this web service. However, Xdata makes it even easier for customers to get to know about your APIs. Xdata has full Swagger support. Swagger, in a nutshell, is a way so that you can show what your web service does and give users the ability to test your web service and see what the different methods produce, which parameters they expect, and what the results look like. Xdata also makes it very easy to define the endpoint your web service runs on. This web service is running on port 2011/weather. The plus is an indication for localhost. So if I were to start this on this computer, I could access it using localhost port 2011/weather. I'm running this web service already on another computer in my network, so I can simply switch on my web browser and access the web service. So the URL is the IP address of my computer, the port 2011, and we need weather as the endpoint that we selected. And we see that Xdata does react. I just get a JSON result. So now we also can access the model in a very technical way. That means, what does this web service offer? This is used also internally by Xdata. It defines all the data points. This would be something you could also give out as a description, but it's very cryptic. So in order to enable these additional information, you just have to enable Swagger, and you have to enable the Swagger UI using these two settings, setting them to enabled. As I already have enabled these settings, I can simply replace add model with Swagger UI, and we get a full-blown user interface with the URL and all the different services that are available. For example, if I want to get the devices that are available, I expand this, and here you see the JSON representation. Again, if you use Xdata, we don't even have to deal with that. But here you see all the values that are being returned. You can also try it out, click try it out, and then you can execute, and then you get a real example from the service. So you see only one device is stored in the database right now, and that's the result. Everything is being documented. You even get the command line if you wanted to execute that request yourself. Everything is very easy to use and transparent for all the other different methods as well. You can also see that we have the post method for adding values and the parameters that are being expected. So everything is very transparent and documented automatically. Zero work involved. You just switch the enabled to true, and this is what you get. So far, I've shown you the representation of the database, I've shown you the service interface, but now we have to bring the two together. We have to link the database to the service result. And for that, I add another data module to my web server project, the Xdata project, and drop an FireDAC manager, which handles everything that has to do with asynchronicity and to request comment to the web service. So the threading, everything will be handled by the FireDAC manager. Drop this component and you will get the functionality. Also, of course, read up in the documentation, the FireDAC documentation, but this component is essential. Otherwise, you will get issues if multiple users or if consecutive requests come into your web service. And then you have to provide a connection to your database. So what I do is, in my database controller, in the data module, I provide a method which is called get connection, and then also one that gets me a TFD query, a query for this connection. So looking at get connection first, I create a new connection using FireDAC connection parameters, add a temporary connection definition for this, and then I return the TFD connection object for each request. And this might sound very, very wasteful. However, pooling makes this all possible. The manager, FireDAC manager, will handle the pooling. So meaning requesting a TFD connection doesn't mean you get a physical connection to the database. You might not have a physical connection request each time you request a TFD connection instance. That is not the case. That is all handled by FireDAC, and it is all very performant. The key is that you use connection definitions and do not try to connect to the database directly just using database server port properties on the TFD connection component. You have to reserve a connection name. That can either be done on the system using a configuration file, or as shown here, using the connection definition setup in source code. Getting a query is really simple. You create a new FD query object without any ownership and assign the connection to the query. So in order to get the devices from the database is really simple. The method, of course, is using the same fingerprint as the web service method. I request the devices and I return a list of T devices. So we create the list, which is the result of the function. We get a new connection or an existing connection from the pool. We get a query object. We get the SQL statement for the query, which is select star from devices. We open the query and then we iterate all the records inside of the query by simply assigning the different field values to the T device instance. And of course, don't forget first to add the device to the list, and then also don't forget to switch to the next record. And of course, this has to all be encapsulated in try finally, that the query gets freed, and also that the connection gets freed. That is very, very important. If you do not free the connection, it will not be returned to the pool, and at some point, that would mean that your web service requests a new physical connection to the database each time, and at some point you reach the maximum number of available connections to your database server, and you will run into issues. So that is how you pretty much build everything. For example, let's look at how would we add a data point for a certain device. So we add a data point, and as a parameter we not use primitive types, we use the tDataPoint type, and what happens is we build the query with parameters. In this case, update or insert into data points. We pass the different fields, and then we set the parameters according to the values in a data point. So, for example, the temperature is assigning to the parameter F inside of the SQL statement, and then a data point.Fahrenheit. Or the device is device.asinteger a data point.device, which is passed through us, and then we can also make sure that we don't get duplicates by using the update or insert into matching syntax, which is very Firebird specific. So there you see the web service bridges into the database. The web service is the one that accesses the database, not you. You just call at data point and you don't know what's going on. If you decide in a couple of years from now to use a different database, or if you want to use different databases right away, this would be the point where you would implement different kinds of databases. However, your customers that use your client wouldn't see that. The final piece of the puzzle that's missing is we have defined the service methods, but we have not implemented the service methods. So that is something you find in the implementation of the service. So this is the UData service, this is the interface. If you go to the implementation, you find, for example, to add a data point. So we simply call the method of the data module TDB controller add data point, and we pass the data point as a parameter to it. Getting the devices, simple, same thing. The function has to return a list of T devices, and we get that from the data module get devices method. Also, be aware I use with a shared, I use a singleton pattern. What I do is I make sure that we only have one instance of TDB controller in the whole application, that we don't have to bother about reserving the memory for the data module or cleaning it. I also don't use the default template var that is defined by Delphi. I use the singleton pattern. The implementation is right here with class function, shared TDB controller, and class destructor destroy. That makes it possible for you to write your service methods really easy using TDB controller.shared and then the method that works on the database. So that really is already the web service. Of course, the other services do the same thing. They bridge into the database, executing the queries and returning the results using Xdata and this service definition. You're also able to, very interestingly, throw exceptions. For example, you can throw an eXdata HTTP exception, and that will then also set the status code of your web service respectively. For example, here we throw a 404 HTTP error for no data point found if there is no data point if you ask for the last data point. Let's move over to the Raspberry Pi application again, because that is the application that actually has to use the web service. So we add the unit with the T data point into the project, because that is something we need to have in order to communicate with the web service. And then on the form, the HTTP request has to be set to HTTP post because it's a post request, and everything else we can do in code. I also encourage you to set the content type to application JSON. This is something we do manually, intentionally. There are Xdata specific web core components, but I intentionally didn't use them here so that we would get an example that is completely independent of Xdata if you have a different web service that needs to take your values that is not written in Xdata. So set the content type appropriately, and then in the timer method, I right now send new data every 10 seconds, and I only send data when I have this check that I want to send data to the web service. So I go to the timer on timer, and this is where all the data is read. But here, if send to web service, I wrote my own method to send the data to the web service. And what we do is we create a new T data point. We set the endpoint. This is hard coded here for demonstration purposes. Of course, you would use some sort of configuration for that. And note that I used weather data service add exactly as it is specified in our definition. Moving over here, you see /data service /add, and we need this JSON body as it is specified right here. And TMS Web Core makes that quite easy. I can create a tData point instance, and then I can use the tjs-json stringify command in order to get the JSON of that object, can set it to the post data of the request. I call execute. I won't wait for the result. I simply send it. The request, of course, gives some sort of response. Where do you find that? Well, if you go to the component, HTTP request, events, here you have the on response, and you can also evaluate errors and stuff like that. So every 10 seconds, we call this method and send the data to the web service. That's it. Now you have a full-blown measuring device which communicates with the outside world and stores its data. Pretty impressive with this little code, if you think about it. Also note that I have helper methods like datetime to Unix, which calculates the epoch date over tdate time value. And I also can use local time to universal, which allows me to get a time which is not depending on my time zone. It's UTC time, so it is valid everywhere. I really think I've tortured you long enough. So here you see my Raspberry Pi, and here you also see that the Raspberry Pi is measuring the temperature right now. You just saw the values flip because I said every 10 seconds I want to measure a new value. Right now the temperature in the room is 23.74 Celsius, humidity is 48, and we just had another update. The air pressure changed a little bit. So today is no sunshine, it's pretty cloudy, so there won't be any changes right now. You just see the humidity, the decimals change a little bit. So the application definitely works. and this is a Raspberry Pi, which I access through a VNC viewer. This is the native application. Here is the Pi directory, which I use to deploy the application, and here is the application, which is 7 megabytes in size, and I believe you can see it looks precisely like the application that we defined in Delphi from the user interface. It's not a very challenging user interface, but it shows that the rapid application development approach works, and most of the time this is like what I see in this kind of application. You wouldn't be using a user interface anyways. The key component is to send the data to the web service. This for me is the most impressive part, I gotta be honest, because if you use Xdata and you make use of its features that it offers to you, you can save a lot of time, because this application does not use any manual encoding, decoding, or whatever of JSON. You just use a component which sadly doesn't have a form representation yet. It is all in code, and it is called txData client. It is a class which is included in the xdata.client unit. Best practice here is, after talking to the engineer, if you use it in a scenario like this, create one xdata client and let the xdata client handle all the objects that you request from the web service, because you can work with objects. You don't have to work with any cryptic strings that you need to decode. You can work with objects. And where do these objects come from? Well, you can honestly include the same Pascal files from the server. You include the data service, which is the interface that you defined. And secondly, you use the model that you define with those classes. Those are the exact same units, as you can see here in the project structure, from the server. And that's the big power, because you don't need to do the same thing twice. You can reuse what you have defined on the server side. And also, you do not give away your implementation of your web service if you hand this out to other customers that want to use your API. Because, look again, the interface just contains the definition of your service. It does not contain the implementation. And that is the key to understand when working with Xdata. You can give away your web service definition. You don't have to give away your implementation. And with this interface, you can use the txData client. Again, I hard-coded the endpoint of the web service. Doesn't matter here. So when we create our form, double-clicking the form, I create the txData client instance and assign the URL. That's it. Then the first step is, if you look at the form, I need the devices. When I have the devices and click on a device, I need the available dates. If I click on a date, I need the available measurements, which are always the same. So this is hard-coded. But if I have the dates, or if I select the date, I need to get the points in the chart. So my data sets that I want to use, thinking like we did starting in Delphi 1, I need a data set for the devices, I need a data set for the dates, and I need a data set for the data points. And again, Xdata gives me that, the T Aurelius dataset. Why is it called T Aurelius dataset? Xdata was built on Aurelius. You don't have to use Aurelius, which is a different product from TMS. The name of the component is because of that, but you do not need to use Aurelius. It is just the name of the component. So getting the devices, and hopefully this will get you hooked on Xdata and this technology right away, because this really shows the power of Delphi and generic classes and interfaces and implementations better than any example I could build or construct. So you know you want a list of devices. So you define a list of devices, and you know that you need the iData service. Remember, this is what we call the service, iData service. That's the interface. So the service that we want, we get from the client, fClient. That's the variable, field variable that we used. So this has a method called service. Let me type it, show you the code completion for that, of T. T is iData service, and it returns a T. So at that point, our L service will be of type iData service. And this is, let me use a little bit of slang here, freaking amazing, because if you type L service, dot, you get all the methods that your web service has to offer. In code, with at compile time, you have data type safety. And this is really, really cool because now you can simply get the list of devices from the web service using lservice.devices. Because in your service interface, you define a method or function called devices. That is really all it takes. Now lDevices will contain a list of instances of type tDevice. You could now iterate these and add them to a combo box, but we'll even do better. We have our devices dataset, right? This is devices. This is a tRadius dataset. And you can call a method on this set source list to assign a list to this dataset. So you assign lDevices to the dataset. So set source list assigns the list of devices to your dataset. Now your dataset will be a representation with fields for the properties or fields of your data type. Please, I just changed you might have noticed I changed the false to true. I had a different memory management approach. The true means that the lDevices, the list, is being freed by the dataset as soon as it is being closed, so we don't have to free this list. So that's something you have to read up in the documentation of Xdata, how these memory management things work, but it's very easy. I think not having to deal with it like this makes it easier than having to deal with it. So we open, after assigning the list, we open the dataset, and that means this dataset with the devices can be tied using a data source, and this data source can be tied to the DB lookup combo box like you've been doing it with other datasets for years and years. So we set the list source to DS devices, and we then set the list field to fname. Remember, it's the name of the field, and the key field is FID to identify the device. And in the event on click for the combo box, we can now say if the user selects one of the devices, get dates, which is a method that we will write now, but with the parameter cbdevices.keyValue, which will be the ID of the device. So let's look at the implementation of get dates. Here we go. It's the same thing as before. We get the service reference. We then get the list of available dates using the method getDates, but we can also pass the ID of the device as a parameter. Remember, we don't have to deal with any JSON or anything here. That is all done by Xdata. So you say dates.close, dates.setSourceList, ldates. We open the dataset, and then we can tie the dates, of course, using a data source again, to this combo box. This combo box, if something changes on click, get data points. Which data points? The data points that match the ID of the device and that match the ID or the date that we selected. So get data points, same thing. We get the service reference, we get the data points, we pass the parameters to this date, a date. We only selected the start date. As we use integers, we can simply, if we, for example, want the points for 1 day, we simply do 60 times 3,600, which is 1 day. And then we can assign these list of points to the data set called points. Again, we open the data set and that's it. How do we charge this? Well, we use a TDB chart, and the TDB chart has its series set to that data set. That's all we need to do. That's all the code we need to write. So if we now start this, again, the web service is still running. We get the list of devices. We click on the devices. We get the list of dates. We click on the day, and there is our temperature. We can even select the different properties that we want to show by switching the data source, the field inside of the chart. So we immediately get the temperatures shown in the chart, and we can also select a different field. That is something that changes the source inside of the series of the chart. For example, if I go to pressure, that's the air pressure, and this is the humidity. So you also see the performance and speed that this works with, which is very quick. What is even more impressive is the fact that we can use methods and data types and classes that we have defined inside of our application in Delphi. This is nothing web service specific, and we don't need to use any cryptic string concatenations, and it's all defined in the language using objects and classes. Also think about how we build the database bridge. We did not have to use any string concatenations. Everything is safe of SQL injections. We used parameters that are being inserted into the SQL statements. This is all safe. And finally, completely loosely coupled from anything Delphi, this is an implementation inside of Swift UI or Swift that reads the data from the web service, showing the current temperature on my iPhone right now. I'm showing that from my iPhone. So you can see it just changed. So the web service connection is really not tied to anything specific that is Xdata specific. You can use any client you want. You can also use PHP, Java, anything's possible. So how do you get started in this wonderful world of web development, web services, databases with Delphi multi-tier development? Well, first of all, TMS has dozens of free tutorials regarding this topic on their YouTube channel. The documentation is more than 500 pages now for TMS Web Core as a PDF. It is free. Tutorial videos and blog posts, there are also many, also freely available on their webpage. Wagner Landgraf did a training course to get started with TMS Web Core, and I have written 2 books about TMS Web Core to get you started, written from the perspective of a Delphi developer, one in English, one in German, that will get you started. However, if you want to dig deeper with these kind of web services, multi-tier database backend, the third book of the hands-on with Delphi series is the one for you, because there I really give a big example about multi-tier cross-platform data access development with TMS Web Core X data. I also give an introduction about the grids that TMS has to offer. And the first hands-on book is about the basics of Xdata, how to get started with a REST web service, how to add authentication, authorization, and also add reporting. That is in book number 1. And if you want to visualize everything on maps, if you are interested in mapping, the big focus of hands-on number 2 is on FNC maps to visualize content on maps, but there's also a little bit about Xdata in there, how to link Xdata to mapping content and stuff like that. So if you're interested in those books, go to flixengineering.com/books. It'll also give detailed explanations on some of the concepts that I only was able to show and not to explain in detail. You'll learn step by step how to build a web service, how to add different services, how to run your web services as Windows services, not just as applications. There's quite a lot of content in there. So thank you so much for your interest in this session, and I'll now be available to take your questions. Hello, hello. I don't know if anybody can hear me. So if somebody would say in the chat if you guys can hear me, I'll even answer some of the questions. Okay, people say they can hear me, so I'm going to cover a couple of questions. Thanks for the feedback at first. Yes, I was shooting for an overview that you get an impression that developing for the Raspberry Pi is not just like a one-way street where you have your application on the Raspberry Pi and then you can do nothing with it. So I wanted to make sure you see that the whole ecosystem is there and you can build whatever application you want. The biggest question I got here is it tied to user interface? As far as I know right now, it is indeed tied to the user interface because it is built on top of the browser. I would make sure if you're interested in developing server applications, command line applications on the Raspberry Pi, to forward this feedback to TMS so they know that there's interest there, that they can maybe look into solutions to make that possible as well. Also about the version of the Raspberry Pi that is being supported, 1, 2, 3, or 4. It depends more on the libraries that you install. And that again has to be answered by TMS support, which libraries you need. The documentation lists a lot of them. So that is definitely something. If you're interested, download the trial, look if it works with your Raspberry Pi. If not, support is included with TMS products. So you can ask them why your device doesn't work or what kind of device you would need. Then HTTPS was also a big issue. Yes, HTTPS is possible, very easy with Xdata. If you run on a Windows system, it is very, very easy. And any TMS web core application, it depends on the web server you use, how easy it is to do HTTPS. The best solution, in my opinion, is to use a proxy for both, because then you can use you as a developer have nothing to do with the encryption. You develop your HTTP version in your Delphi IDE. Everything is HTTP, your web service and your web application. And then when you deploy the application, that environment, you use HTTPS addresses instead of HTTP. The TX data client component is indeed part of Xdata. So if you have Xdata, which is part of the business suite, you also have the TX data client, which will install into the IDE as a component that can be used inside of the VCL FireMonkey as well. So if you want to write a client in FireMonkey, you have TX data client as well. I don't know if I mentioned it in this session, but TX data client, the only reason it is not available in TMS Web Core is the reason because we don't have RTTI inside of TMS Web Core. So there you will still have to parse the JSON a little bit more, but on TMS Web Core you also have a special JSON data set available that you can use to hook up a TWeb data source in order to make that happen. Yes, TMS Web Core does run under the Community Edition. I also would like to point out that in addition to the trial edition, there is a free academic version out there. And I think there's even something academic for Xdata available. I'm not sure 100%. Xdata is indeed multi-platform, so you can compile Xdata also for Linux, something that I haven't mentioned. So if you have a Linux server, you can run your web service on a Linux machine as well. And then I have to expand this column a little bit more. What is going on here? I can't read the one new feature. No, you can't. I mean, this is web applications, yes. So high DPI is not a factor for the web application because the web browser renders the content. As already answered, console application. Yes, you can definitely use stuff from a PLC, from a real PLC. Somebody's asking for a Siemens Step 7. Yes, if the Siemens Step 7 has web services enabled, you can definitely query those from your TMS web core or from your, the Raspberry Pi application can also, that is something, of course, I haven't shown. The Raspberry Pi can, of course, collect information from other web services provided by a real PLC, for example. Yes, it is indeed that it runs natively on the Raspberry Pi. That's the next question here. The application is a real native application on the Raspberry Pi. It is not a web application that requires anything. It's a real native application that runs on that processor. The next question is here. Oh, the website for my books, it's flexengineering.com. I'll type that in the chat, and then /books. You'll also find it if you go to the TMS website and look at the documentation. My books are there listed as well. And yes, there is an academic license. I already answered that questions. And okay, so I get the word from Embarcadero that we need to wrap it up. Thank you so much for your interest in this session. If you have questions, you have my email, you have the support email from TMS, and there's also the form. So we would love to hear from you about what you think about this, in my opinion, great new product. And thank you again. See you soon.
All right, thanks everyone for joining. Feel free to check in on the replays once we've actually posted them. So we'll be moving on to the next session. We'll see you there. Thanks everyone.